Have you ever looked up at the night sky and wondered if we're really alone in the universe? This vast cosmic sea, swirling with galaxies, stars and planets, is a sight to behold. But it also brings forth a question that's been baffling us for centuries. In this seemingly infinite universe, with its countless galaxies, each teeming with millions of stars and their planets, the probability of extraterrestrial life seems highly likely. Yet we've never had any contact or found any evidence of such civilizations. This contradiction is known as the Fermi paradox. Named after physicist Enrico Fermi, it ponders the high probability of alien life and the stark lack of evidence or contact. The universe is a grand cosmic stage filled to the brim with countless planets. It seems unlikely that Earth is the only one hosting life. So, if the universe is teeming with planets, where are all the aliens? In 1961, a scientist named Frank Drake proposed an equation to estimate the number of advanced civilizations in our galaxy. For the uninitiated, this equation might seem like a cryptic string of symbols, but each symbol represents a crucial variable in our quest to find extraterrestrial life. First, let's consider the rate of star formation. With billions of stars in the Milky Way alone, it's a vast cosmic lottery. Then we need to think about the fraction of those stars with planetary systems, and of those, the number of planets that could potentially support life. But life's emergence is not guaranteed. So we must also consider the fraction of these life-supporting planets on which life actually appears, and furthermore the fraction of life that evolves into intelligent beings. Finally, we ponder the length of time such civilizations release detectable signals into space. According to the Drake equation, we should not be alone, but again, where is everybody? One possible answer to the Fermi paradox is the concept of the Great Filter. Picture a barrier, invisible and insurmountable, standing between life and the stars. This is the essence of the Great Filter, a theoretical blockade that halts civilizations in their tracks, preventing them from colonizing the universe. The filter could manifest in many forms, each more daunting than the last. It might be a natural disaster on a cosmic scale, like a gamma-ray burst or a catastrophic asteroid impact. It might be a self-inflicted catastrophe such as a nuclear war or an ecological disaster, or perhaps it's a technological hurdle, a challenge so complex and immense that it's nearly impossible to overcome. The implications of the Great Filter are as intriguing as they are terrifying. If such a barrier exists, it raises the question, where does humanity stand? Have we already passed the Great Filter, making us one of the rare, lucky species that have managed to survive against all odds? Or does the filter lie ahead of us, a grim fate that we are yet to face? The Great Filter theory could explain why we've been met with nothing but silence in our search for extraterrestrial life. It suggests that the universe might be littered with civilizations that didn't make it past their own Great Filter. The Great Filter could explain the silence in the cosmos, but it's a chilling thought, isn't it? Despite the silence, we haven't stopped listening. For years, organizations such as SETI, the Search for Extraterrestrial Intelligence, have been working tirelessly, using radio telescopes to scan the skies. They are searching for any hint of a signal, a whisper from the cosmos, that we are not alone. They've had intriguing moments like the WOW signal, an intense radio signal detected by Dr. Jerry Amen in 1977. This signal, originating from the constellation Sagittarius, lasted for a full 72 seconds and has never been explained or detected again. More recently, we've been puzzled by fast radio bursts, or FRBs. These are intense millisecond-long radio waves that originate from galaxies far, far away. The nature of these bursts is still a mystery, but they provide tantalizing hints that there might be more happening in our universe than we currently understand. And it's not just about listening. We also send out space probes and rovers to our neighboring planets and beyond. We've peered beneath the icy surface of Jupiter's moon Europa, roved the red soil of Mars, and sent probes to the farthest reaches of our solar system, all in the hope of finding signs of life. We may not have found them yet, but the search for extraterrestrial life continues. After all, in a universe so vast, it's hard to believe we're truly alone.